So, hi everyone, what's up? I'm here to talk to you about Terraform practices, the good, the bad, and the ugly. I'm a little bit sick, so if I cough, I will try to do it to the other way so it wouldn't be to the mic. So apologies for that in advance. So Terraform is a great tool, right? It is used widely across the world. I'm from Israel, we use it there. Everyone is using Terraform. And this talk will cover not only the specific bits and pieces in regards of using Terraform, but also hopefully will make you think about Terraform in a broader context rather than just an infrastructure as code tool. So first of all, hi, my name is Hila Fish. I'm a senior DevOps engineer and I work for Wix. I have 15 years of experience in the tech industry. I'm a DevOps culture fan. I'm co-organizer of DevOpsDays Tel Aviv, and as mentioned, and Statscraft, which is a monitoring conference. I'm a mentor in courses and communities, and I'm a lead singer in a cover band, which is a lot of fun. Okay, so Terraform implementations, they can be sometimes good, bad, and also sometimes ugly. Small disclaimer, I'm gonna show here examples from mostly AWS stuff, but everything that I will say here applies to any cloud provider. And I used only Terraform open source, so I assume stuff will apply also to enterprise and cloud, but it's usually mostly for open source. Okay, quick wins. When I say quick wins, I mean stuff that you can achieve in a matter of minutes when working with Terraform. So first of all, versions lock. Same as when you work with Python and requirements.txt or packages JSON lock, right? Also, Terraform has syntax that is acceptable and features that are in that version. So you should always aim to lock the versions. You can lock them in 3 levels. So the modules, the providers, and the Terraform itself. This is how you do it. And it's really good because that way you know exactly what is kept in that version. This is a meme from Anton Babenko, who's like a Terraform celeb. If you don't know him, follow him because he's really great. And as you can see, you want to manage infrastructure as code, and then sometimes Terraform AWS provider issues got in the way. So if you lock your versions, at least you deal with the devil that you know. Okay, so the good thing here is to lock the modules, providers, and Terraform versions. This is awesome. The bad thing is to lock in a way that will still allow breaking changes to occur, because if you choose to lock to let's say a minor version and not a major one, then breaking changes will go through and it's not good. And the other thing is to lock, to have no versions lock, which is not good. You will have syntax issues, error issues, so try to avoid that. Next up, tagging resources. It's always good to tag resources because it will allow you to filter your cloud provider expenses and sort them by tags to distinguish between resources. And it will also allow you to gain visibility and ownership on overall by tagging according to the logical breakdown that you have. So these are some tags that we use. Managed by Terraform is one of those that you can distinguish between resources that created by Terraform or not. So the good thing is to tag everything that you can. Really, FinOps team will give you a great thank you for that. So it's always good to tag. You can use default tags on the provider level. That way, it doesn't matter which resource you create in that provider. Every resource will get that tag. So for example, if you put the managed by Terraform tag in the default tags, then automatically all resources will get that tag. So that's awesome. And another good thing is to have pull request enforcement to fail a PR merge if someone didn't add tags to the resource. I will cover it in a little bit later. The bad thing, to tag inconsistently because consistency is key. And the ugly thing is to have no tags whatsoever. Again, FinOps teams will have hard time to cover the expenses. And the next thing on the quick wins, remote state. Terraform works by default with local state. That way, you can't really you work with other people. You have the state locally, so you should always aim to have your state locally. This is an example for S3 bucket where you can keep it. So state should be remote and secured. The state should be backed up. So for example, if you use S3 as your backend, then enable versioning. You should ensure the state gets locked when you run Terraform apply to avoid conflicts. And the bad and the ugly thing is basically the other way around. So local state, the state is remote but not secured, and the state doesn't get locked while you run Terraform apply. Okay, so we talked about quick wins, right? Let's talk a bit about second nature. And when I say second nature, I mean stuff that you should think about on your day-to-day when you work with Terraform. So first of all, models and the usage of community models versus creating the models yourself. So the thing with community models is they are proven over time and they are supported by the community, and you eliminate the need to support it and keep it up to date because they do it for you. So really, a lot of well-known cloud provider features are already covered by models. So do your research, see if there are models that are already out there that you can use and leverage, and that's that. So use official community models wherever possible if the use case is okay. If not, then don't force it. The bad thing is writing your own model while official one exists, but if you still maintain it as such with high quality state and practices enforcement that I will cover in a bit that will make sure the code is in a high quality state, then it's still quite okay. And using community model without a version lock, it will also be a bad thing. And the other thing is to have to write your own models and have no checks or consistency whatsoever, and no code practices applied. Trust me, it will be down a rabbit hole pretty fast. And if you do have to create your own models, then make sure you make them stateless and clean and generic, and try to not repeat yourself. If you don't have to, keep the models as simple as possible, and use enforcement to make sure that the code is kept in a high quality state. Variables and locals. So unlike variable values, the local values can use dynamic expressions and resource arguments. Locals also don't change values during Terraform runs, like plan, apply, or destroy. And you can use locals to give a name to the result of any Terraform expression and reuse that name throughout your configuration. So like this example here, I set up some variables, and then I can use these variables to have a final definition of how my tags should look like, and this will get used in the entire module usage that I'm having. So on the module side, set up variables as needed settings for module configuration, and you should always set default or validation to variables, because if not, if someone uses the module and doesn't pass values to that variable, then the module will get break, and it's not nice. So always set a default or validation. And in regards to locals, you should consider them as a constant to be honored or relied on. So for example, if I have a model to create a S3 bucket, and I want to have naming convention, so everyone that uses that model will have the same naming convention for all the buckets. So I can achieve that by setting this local right here. On the live side, and when I say live, I mean the part where I call the models themselves. So on the live side, if I use variables once, I can just set default on the variable and that's that. But if I use variables per region and stuff like that, then we should use a tfvars file. You should avoid using locals if you don't need to, because live side should be kept as simple as possible with little to no logic. And you should use data sources to pass their outputs to the model, because if we can use and utilize stuff that already exists and have dynamic updates to it, then we should always leverage that. So to sum things up in regards to variables and locals, use tfvars wherever possible and necessary. Utilize environment variables, because if you have environment variables that you can utilize, then it avoids the need to create more variables to maintain. You should use locals to de-hard code names and tags, etc., which are set only once, or to decrease code repeatability, and keep things generic as much as possible. The bad thing is to use multiple local blocks if not necessary, because again, we want to have a readable code. So multiple blocks is not, if not necessary, don't do it, and ignoring environment variables. And the other thing, hard code values for variables, because variables should be, variations of stuff. Okay, so let's talk now a bit about file structure. So as we know, Terraform will execute all files that has the suffix of tf, but we do need to have a file structure with naming convention that matters, because that way it will allow better logical arrangement and easy management. So we can take example from the community standard as well. So in the community models, the main logic of the model is kept in main TF, and then we have variables, data, and outputs. And if you have other stuff, other peripheral stuff that accompanies that main logic, then it should be in separate files. So for example, if I have a model to create a VM, then the creation of the VM will be in main TF, but then if I need security groups or a load balancer, I will put them in separate files. And another thing is that if you created a model, for example, that is pretty much complex, you should break it down to sub-models. Why? Because that way the variables will be only like a small file, not gigantic, and it will be easier to maintain. And you can also see that in community standard, the EKS module has a sub-module of node pool creation, and a VPC module has a sub-module of VPC endpoint. And so I'm gonna cough just a sec. I'm sorry about that. Okay, next up is applying classic code best practices on Terraform. So yeah, don't worry, I don't think the Terraform is a classic and pure programming language. We all know that it's not, but similar rules of writing code apply to Terraform as well. Even HashiCorp, the company that created Terraform, realized that because before Terraform 0.13, you couldn't even loop over modules, and since that version got released, you can loop over modules with a single module call. So principles of classic code best practices should apply to Terraform. So keep your Terraform code base in source code management like GitHub, GitLab, whatever you choose. Keep the code as simple as possible, simple, stupid. Do not repeat yourself if you don't have to. Keep the code idempotent, and even principles of functional programming can be applied on Terraform as well. And in regards to human and clean, I want to quote something by Tix and Guo. It's an article I found online, great article. He basically said that computer that processes your code doesn't care if the variables are ambiguous or inaccurate, right? If the code is in a proper syntax, it will get executed anyway. But the things like refactoring and clean code and naming conventions are meant for us human beings to be able to read the code better and maintain it. So not for the sake of computers, but for the sake of us human beings. So please, as you can see, it's only the angel here. I don't see any bad thing to do with applying classic code best practices on Terraform, so please try to do it. Everyone will thank you, your team members that will need to maintain your code after you, so there's that. Okay, so we spoke about quick wins, stuff that you could achieve in a matter of minutes when you deal with Terraform. We spoke about second nature, stuff that you should think about in your day-to-day when you deal with Terraform. Let's talk about the long haul. And when I'm talking about the long haul, I mean stuff that you should plan ahead and think about, and really think in the long run when you are dealing with Terraform and you want to work with it for the long term. So structuring your Terraform code base. How do you structure a Terraform code base, right? There are a lot of ways to do it, and I want to show you how we do it in Wix. So in Wix, we have this structure: team, project, cloud provider, and region. This is an example, so there's like the live and the modules for the root structure, and then BI for team, Airflow for project, AWS for cloud provider, and US East 1 for region. Why did we choose this structure? Two reasons. First reason, to have Terraform as a platform, because in Wix we have like something we call the Wix way. Everyone is using the same technology for the entire company. So that way, the entire company on all the teams that we have can use the same Terraform in the same code repository. Each team is responsible for their part, because you see it's by team, and we have code owners defined in GitHub, and that way they can improve their own PRs and stuff like that, so they have their independence. And we still have practices enforcement, which I will cover in a bit, that will make sure that the code is in a high state. So this is one way, because we want to enable others in their Terraform journey in the company and have alignment while doing that. And the other reason for choosing this structure is because in this structure, the Terraform state is kept there in US East 1. So it means that these are a state only for Airflow project, for BI team in US East 1 in AWS. So a very small state, And why is a small state important? Because Terraform creates a dependency tree. So and sometimes Terraform doesn't do a great way in that. So we need to help Terraform do its work properly and have valid dependencies. So if we have small states, then the dependencies trees will be quite okay, and then you wouldn't face stuff like I change X on the code base, and then on the plan I see that it's gonna change other resources that I didn't plan to change because of the invalid dependencies. So small states will prevent a big blast radius, which you always want to aim to that way. Okay, workspaces are not really related to structuring the code base, but it is something that Terraform offers, so let's talk a bit about workspaces. So workspaces isolate their state, so if you run Terraform plan, Terraform will not see any existing state for this configuration outside of that workspace. So that's why workspace is good for when you have the same Terraform config, but for different customers. So let's say I have different GCP projects. Each project is a customer. So each customer is a different workspace because they all have the same configuration, just different customers. So this is one case to use workspace. Another one, which is basically coupled with the previous one, is that I have different customers, but everyone should use the same financial service or the same login service, right, in different region. So also this service could be in a different workspace as well. Some notes about workspaces: you should really consider using Terraform wrapper to avoid human errors, because how do you use workspaces? With CLI, Terraform workspace select X. So if I forgot to do this select, I'm basically not good, okay? I can't swear on stage. So that's the thing. There will be less visibility when working with workspaces, especially if you don't use the Terraform workspace built-in variable. So less visibility, it's not nice. And even if you do Terraform workspace list and check out that you have like 5 or 6 workspaces, it doesn't mean that they are in use. So always think ahead and really plan ahead if you are okay with working with workspaces with less visibility, and if it really fits your use case, because it has some quirks to it. And something more about workspaces from the Terraform documentation that I want to read to you is that they say use workspaces to manage multiple non-overlapping groups of resources with the same configuration. So it suggests that these usages are qualified, right? Multiple environments, dev staging production, multiple regions, locations, accounts, all sorts of things, right? But also from the Terraform documentation, they say that multiple deployments of the same infrastructure serving different development stages, e.g. staging versus production, named workspaces are not a suitable isolation mechanism for this scenario. So I don't know, in my entire career, I haven't had the same infrastructure serving both dev and production. So if this raised a question to me, maybe it will be to you as well. So just think things through before you go down this whole this path. And at least we can all agree on one workspace usage, like side branch. So if you have your main production infrastructure, the default workspace, you can create a new workspace, do whatever changes that you need, syntax-wise, resources-wise, apply them separately, and once all looks okay, then apply them back on the default workspace. Okay, so to sum things up in regards to structuring your Terraform code base, if you really plan ahead and you really think about how to structure the code base, it will allow you to set up small states, which is good because we don't want big blast radius, and it will allow you to set up Terraform as a platform and enable anyone in the team or in the company to use Terraform, and in a high quality state because of the practice and enforcement that I'm covering in a bit. Sorry. Sorry about that. The bad thing here is that if you have organizational changes, they could require a restructure of the code, and you don't want that. You want to be able to have control of what's going on and not be, liable to any uncontrolled changes. So that's that. And using workspaces for the wrong reasons could also be quite bad, as I just showed you. And the ugly thing here is to structure the code base in a way that will allow huge states, because again, invalid dependencies, big blast radius, I had like stuff that I changed, and then the plan showed entirely different resources, and it just down a rabbit hole that you don't want to go to. So structure the code base in a way that will allow small states setup. Okay, Terraform execution. So I will breeze through it because it's pretty simple. So always aim to remote execution, because that way you avoid local credentials and local configurations. So remote execution for the win. Run apply with the plan file so you know exactly what is gets applied, and set up a Terraform timeout, because sometimes I had to create auto-scaling groups with spot instances, and then the price wasn't right, and then I had to wait and wait and wait because the price was too cheap. So set up a Terraform timeout that is reasonable to you. The bad thing is to execute locally, because then again, no audit, you need local credentials, local configurations, it's not nice. And the ugly thing here is to execute locally and run Ctrl-C when you run Terraform apply. I did it okay, you know. So I did it when I just started out with Terraform. I was impatient. I was like, the timeout doesn't matter. I did Ctrl-C, and then it messed up my state. So please, I don't know if they changed it by now, but I don't want to find out. So, okay, practice enforcement. I covered it. I mentioned it in a bit, like throughout the presentation so far. So let's talk about it. Practice enforcement means that a lot of people uses Terraform, right? Either in your team, if you have a big team, or like in Wix, with the entire company uses that. We want to make sure that the code that gets introduced to the code base is in high quality state. Why? Because we need to maintain it for the long run. And also, we might have some guidelines that we want to enforce. Like in Wix, we have the failing PR merge if someone didn't add tags, because we want all our resources to be tagged. So if you have any guidelines of your own, could be best practices in general, or just stuff that you have specifically in your company, like we need to inform team X whenever X happens, right? So it could be anything that you want. And these practices enforcement also happen in most, I think, of community models, so that which allows people to contribute to the code base as well. And I'm going to show you right here. So this model is Terraform AWS auto-scaling, Terraform AWS auto-scaling model, sorry, which is also got created by Anton Babenko, the Terraform celeb that I mentioned before. And he added these tests. So he checks if the contributor formats the code and add documentation and write the working code. He incorporated TF-lint here. So really, these tests are great to check if the code is in a high quality state. But again, it could be whatever best practices and guidelines that you want to enforce whenever people try to commit code to Terraform. So also here, as you can see, only the angel, I can think about anything bad to say about practice enforcement. It's only good in my opinion. So it could be pre-commit or pre-merge linters, formatters, and logical checks. It could be done through GitHub Actions or CI pipeline checks. In Wix, we have GitHub Actions with Atlantis in the background. So when I open a PR, GitHub Action runs and executes Atlantis plan. I see the plan, I see that everything looks okay, and then when I type Atlantis apply, two things happen. First, the code gets applied, the infrastructure gets created, and then the code gets merged to main, which is good because we always want to have the practices enforcement check that our main branch is always the same as the actual environment, because we don't want to have drifts, right? But if you do have drifts, so consider maybe creating a Slack bot that will detect and report drifts, and then you can do something about it. And on the right, you can see some open source enforcement and helpers to help you in your journey of integrating practices enforcement in your code base. Okay, so I spoke a bit really about a lot of things here, right, about Terraform. So if there's something that I want you to take from this presentation is one simple question. When you work with Terraform, you should really ask yourself, how do you envision the infrastructure and the company needs? Because you should really think things through, and planning ahead will allow you to enable others in their Terraform journey, because if we didn't plan ahead, then we wouldn't be able to do that in Wix as well. And you will be able to set up guidelines and best practices of your own, like tagging usage that we do in Wix, and structuring models and Terraform usage in general. So it really is important to plan ahead, and it will allow you to utilize Terraform in the best way possible. And really take into consideration, I mean, I don't know if it's big enough, you tell me, but that's the main idea. You should really take into consideration your use cases and your pain points and Terraform constraints, of course, and where do you see the infrastructure management and company needs in the long term, and plan accordingly. Because again, planning is really important, especially when something is done throughout the entire company like we have in Wix. So even if you're a startup, you should really think about scale and how should you address and prepare for changes to come, and then you'll be able to utilize Terraform in a great way. And I also want to quote something else from Tix and Go, the article that I mentioned before. Programs evolve, right, and code changes, and it is really uncommon that you write Terraform in one way and it stays like that, because if so, I wouldn't even be here talking to you about Terraform practices, because everyone would just write Terraform in one way, that's it, continue with their lives, and that's that. But it's not how stuff works, it's not how projects work, and companies want to evolve. And how does a company evolve? With projects, going from the current state to the next desired state. It's also a project, right? So you should think about how to structure Terraform and treat Terraform generally, because that way you will allow projects to get evolved and introduced to your environment, and then you will help your company improve and contribute to the company's success. So thank you so much, and if you have any questions, let me know.
Okay, I get to toss this thing. I saw a hand up. Okay, we're gonna try it for a long haul.
Hi.
Hey.
So I have a question on the version checks. So I experience in one of my other infrastructure where like I use a Ruby Gems, and I use the parent provider Gems, and but the dependent providers, they change something, and my all infrastructure code, my infrastructure was broken. So could you please suggest anything in the Terraform if something happen? What is the best practice, or like how we can try to avoid on the version?
So you mean if you haven't locked the versions of the provider?
In that infrastructure in the James, I lock the version for the parent provider, but something changed into the dependent, because parent provider, they have some other provider dependency, right? I'm not sure if they have lock on that one, but they changed the dependent provider, and that broke my code that I logged for the parent provider.
Okay, so when the thing with locking versions is when you lock the versions and then you run Terraform and you try to run Terraform plan, then it says, no, please run Terraform in it, because it wants to download that specific version that you set up. So when it does it, it should calculate the dependencies of the provider also. So if one provider has dependency of another and you lock them both, it should be okay. It should alert you that if something went wrong. But if it's not the case, I haven't experienced that, so I'm not sure what I would do in that case, but I would just try to go down like one step at a time to see how it can be fixed. But I also would check online for the documentation to see if there are known issues about some versions that they say skip them and use different ones. So just like a mixture between reading documentation to see what to expect and just fixing stuff one by one. That's what I would do.
All right, got another one right here.
Hey, thanks for the presentation, but quick question. Do you think there's ever a situation where you're over nesting modules?
Yeah, I think people can get a tendency to overcomplicate stuff. So that's why the principle of keep it simple, stupid applies, because we want to have simple stuff as much as possible. So if you do experience like too many nested things, you can just create another version of that module and then simplify it then. And that's why you can have versions for modules as well. So if you understood that you made a mistake and it's too nested, you can invest some time in restructuring that and have a version, another version that simplifies that. That's what I would do.
Got it. So you mentioned Terraform workspaces are probably not the best idea for environments, right? Selecting environments. What would be the best way to go about that? Would it just be nesting different Terraform directories, or?
So in regards of variables, so they use, there's the TF-var, so you can use it to utilize that.
Mm-hmm.
This is what we did in my previous work. We just utilized the TF-vars, and that way we divided like that. But as you've seen, the structure of the code base that we have, it is based on regions. So we don't really, it is a little bit of a code duplication in some sort because it is in a region level and not higher above, but it's worth it because it allows you to have better readability. So the principle of do not repeat yourself is like it's with an asterisk, right? It's only when it's worth it. So if you see that overcomplicating stuff as opposed to repeating yourself, then repeating yourself is the better way, then choose that because it's not really repeating while when it's worth it, it's worth it. You will feel it, in your day-to-day. So that's why we decided to do that like that, and we don't really feel that it's too much of a burden. So.
Another one over here.
Hi,
Hey.
thank you so much for the presentation. How do you feel about using Terraform, not just for your infrastructure, but for code deployments as well?
In my previous company, we had Terraform like as a bundle to deploy also Kubernetes secrets and deployments and everything. It worked well. I can't say it can't. It didn't. It did work well. You need to structure it in a way that stuff looks coherent enough to understand, but it works well. The Kubernetes provider for me works perfectly. I didn't have much issues with that. So there are two aspects to it. One say no, we should separate and have Terraform create only infrastructure, and the other part say we should bundle it everything. I had some issues with, let's say, when people wanted to deploy stuff to Kubernetes, they had to upgrade, run Terraform apply as well because it was in the same place and they didn't quite get it. But once you educate the people and tell them that, hey, things are coupled together. If you deploy a code change that requires a pub/sub in GCP and you have Terraform to create that pub/sub, then you make them realize then that stuff really coupled together. So once they have this mind shift, then they understand that it's okay. We had some Terraform failures, of course, but usually Terraform errors there could be some ambiguous ones, but usually it is okay. So in my experience, putting everything together can work, and we did it in my previous company, it was for 1,000 of Kubernetes clusters, and it worked. So for me, it works, and it was okay. If you have different complex environment that doesn't worth it because you have too many layers of abstraction that prevent you from doing a good work, then you should maybe forsaken it. But I feel that it's a good practice.
Thank you so much.
Thank you so much, guys.